Some best matches are correct. That is, you pull out the best one, and it really is the right point. But some of them are not. The most important thing, though, back like we did in the Hough transform, the ones that are not are just sort of random. They're voting for Mickey Mouse, Santa Claus, Donald Duck. They're not all voting for some other particular wrong transformation. Not that there's anything wrong with Donald Duck, but he would make a poor governor. Although given some of the other governors, whatever. Anyway, so what we need to do is we want to find the right ones so that we can compute the pose, the transform, the fundamental matrix, whatever it is, the model. Okay, so this is the model that we want to compute. And today we're going to talk about this algorithm called random sample consensus, or RANSAC. So to talk about how this works, go back to our simplest example of fitting a line. So here we have some points, and if I were to ask you to fit a line, you'd probably say, well, that's the correct line, that line that kind of goes through most of the points, and somehow ignores that bad point. You're going to say, aha, that's right. Remember Evil Megan? That was the Evil Megan point. The problem is, if we don't know that that's an Evil Megan point and we actually include it in, say, our least squares fit, we were showing you that our best fit line was not such a good one. And really what's happening, before we talked about robust estimators, what's really happened is you're just not going to get points like that from a Gaussian distribution. That is such a low probability. That point comes from outside our model. And so we have to figure out somehow that it's one of these outliers that's outside of our model.